This is the Module 5 CBA review for PreAP. On level had a couple different questions, so this is going to be the PreAP review, and then we'll have a separate video for on level. Obviously, here are your learning objectives up type. This CBA is over rational numbers and the Cartesian plane. So let's go ahead and get started. In which quadrant is each point located if the ordered pair has the following signs? So what I would go ahead and do is I'm going to draw a plane up here. And then the way I tell my kiddos to remember it is to draw the letter C, and then we follow it around. So this is quadrant 1, we follow the C to this here, this is quadrant 2, this is quadrant 3, and then this is quadrant 4. And because these are like number lines, this is my point of origin. If I go to the right and up in quadrant 1, this will be positive and positive. So it's positive, positive. Here I would go negative first, and then up would be positive. Here would be negative and down, so those would both be negative. And then in this one, I'd be positive x, negative y. Okay, so that makes it easier for me to do my answers. Positive, positive, that's quadrant 1. Negative, negative is quadrant 3. Positive, negative is quadrant 4. And negative, positive is quadrant 2. Number 2. Michelle brought home 3/4 of a pizza for lunch. She ate 1/3 of what she brought home. What fractional part of the pizza is left? So this is a multiplication problem because I want to know what 1/3 of the 3/4 is. And you could draw a picture, but it's really easy just to multiply. So I'm going to do 3/4 times 1/3. When we multiply fractions, we just multiply straight across. 3 times 1 is 3. 4 times 3 is 12. I could leave my answer like this, but it is not simplified all the way because I can divide both my numerator and my denominator by 3. So my final answer would be 1/4. Number 3. Order the following numbers from least to greatest. I have 5, negative 5.5, negative 5.05, and 5.55. And I'm going least to greatest. So on my number line, the number that is the furthest to the left from 0, which is in the negatives, will be the smallest. And that's going to be negative 5.5. Next, I'm going to have negative 5.05, followed by 5, and then finally 5.55. That would be in order from least to greatest. Number 4, determine if each statement is true or false. We start with 10 halves is a whole number, an integer, and a rational number. Well, 10 halves is equal to 5 if I do 10 divided by 2, which is a whole number, it is an integer, and it is a rational number, so that is true. Negative 25 hundredths is an integer and a rational number. Well, it is a rational number, but it is not an integer because fractions and decimals cannot be integers, so this is false. Negative 4 is a whole number, integer, and rational number. It's an integer and it's a rational number, but it is not a whole number. Whole numbers do not include negative numbers, so that is false. Negative 16 halves is a rational number and an integer, but not a whole number. Negative 16 halves is equal to negative 8. That is a rational number. That is an integer, but yes, that's not a whole number, so this is true. Negative 1.5 is a rational number, which is true, but not a whole number or an integer. That is true also. The reason it's not an integer, which I know people get confused because it's negative 1.5, but because it has that decimal, integers cannot be decimals. So this would be true. 7 is a whole number, an integer, and a rational number. 7 is a whole number, 7 is an integer, and 7 is a rational number, so this is true. Number 5, draw a model to represent each number sentence. So we have 2 times 3 is 6. So I'm going to show 2 groups of positive 3. So there's my one group, and there's 2 groups. So that shows 2 groups of positive 3, and I have a total of 6. 2 times negative 3 equals negative 6. So now I'm going to show 2 groups of negative 3. There's one group, and here's 2 groups. So now I have 2 groups of negative 3, which is showing negative 6. Number 6, what is the absolute value of 3 halves? Well, the absolute value is the distance away from 0 on a number line. So 3 halves would be 3 halves away from 0. So we can just leave that as an improper fraction and put it as 3 halves. If you wrote that as 1.5, that would not be incorrect because it's still 1.5 away from 0. What is the opposite of 3 halves? That would be negative 3 halves. That would be the opposite. Okay, again, if you wrote it as negative 1.5, also would be correct. Plot the absolute value and the opposite of 3 halves on the number line shown below. So I need to show negative 3 halves and I need to show the absolute value. So I'm going to draw a dot here, and I'm going to draw a dot here. Okay, so my first one is falling in between 1 and 2 because that's showing the absolute value of 3 halves, which is 3 halves or 1.5. And then the opposite of that would be negative 3 halves or negative 1.5, and so I have a dot between negative 1 and negative 2. Solve the following problem. Okay, so we're going to start by adding our 147 and 63 hundredths plus 420 because that is in parentheses, so we would do that first. So when we add that up, we get 567 and 63 hundredths. And now I need to divide that by 21. So 567, and I'm going to be using long division, so hopefully you have brushed up on your long division and don't necessarily need big 7. Because there's a decimal, I'm going to bring it straight up, and that's where it's going to fall in my answer. Now I'm going to treat it like normal. 21 doesn't go into 5, but it does go into 56, and it goes in twice. 2 times 21 is 42, and I would get a remainder of 14. Then I'm going to bring down my 7. So now 21 goes into 147 7 times, and it's exactly 147 with no remainder. Now I bring down my 6. This is where it gets tricky. 21 does not go into 6, so I have to put a 0 because I'm skipping that place value. Then I'm going to bring down my 3, and 21 goes into 63 3 times, and that's exactly 63 with no remainder. So the answer to this would be 27 and 3 hundredths. On the back, number 8. Line segment AB is plotted on the coordinate plane. Plot and label points C and D so that it is a parallelogram ABCD with a height of 2 units is formed. Draw the parallelogram. Okay, parallelogram can be a square, it can be a rectangle, it can be a rhombus, it can be a quadrilateral of pretty much of any kind as long as there are 2 sets of parallel lines. Okay, I'm going to draw what we traditionally think of as a parallelogram, but if you drew a rectangle, this would not be incorrect. The biggest thing is the height of 2 units. So what that's going to tell me is I need to go down 2 units. So I'm at 6, 5 would be 1 unit, 4 would be another unit. So my line basically needs to fall on that 4 y point. So I'm going to put a point here and a point here. Again, this could be more extreme, you could angle it more, but these would be my points, and when I connect them, you can see that I have a parallelogram, and the height is 2 units. So the point I made for right here would be 2, 4, and the point I made here would be -3, 4. Again, noticing that both of my y coordinates are 4. Number 9, determine if each point is inside the rectangle but outside of quadrant 2. So we want it in the rectangle but outside quadrant 2. Right? Yes. Inside the rectangle, outside quadrant 2. Okay, I had to make double check. So I'm just going to plot them all and then we'll see what's what. My first point is 6, 2. So I'm going to go over 6. 1, 2, 3, 4, 5, 6, and up to 1, 2. So that is not inside the rectangle, but it is outside of quadrant 2. So basically that's no, not inside the rectangle, but it is outside of quadrant 2. But it's not. But we want in the rectangle out of quadrant 2. So that's not right. -2, 2. So 1, 2, up 2. Okay, that's in the rectangle, yes, but it is in quadrant 2 because this is my 1, 2, 3, 4. I probably should have done that first. Because it's in quadrant 2, that's still no, because we wanted it inside the rectangle, but not in quadrant 2. -3, -1. So 1, 2, 3, -1 is down here. So that is in the rectangle, but outside quadrant 2. So that one works. And then 3, -7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That's all the way down here. So again, not in the rectangle, but also not in quadrant 2. Number 10, plot the following numbers on the number line shown below. Okay, so I have -1 and I have -2, and all my numbers are in between. So I'm going to go ahead and mark this as 0.1, knowing that that's -1.1, -1.2, -1.3, -1.4, -1.5, and so on. That way I can just kind of keep track of what I'm doing. Okay, I know that -1 1/3 is going to look like -1.3 repeating, because I just know 1/3 is that 0.333 repeating. -1 1/4 is going to be -1.25. -7/8 we should know from when we did the purpose games a while back, if you did those, that 7/8 is the fraction, or the decimal 0.875. Hopefully we remember that from, we see it constantly. So this will just be -0.875, and because there's no 1, so it's actually going to fall over here. And then we have -1 2/5, which is -1.4. So let's go ahead and mark those. -1.4 will fall right here. That's pretty easy. So I've plotted that, and now I can label that -1, and I'm going to put it back in its original form of 2/5. So I'm done with that one. Negative 1.25, I'm going to plot that because that's pretty easy to go in between. So that's going to be negative 1 1/4. That'll fall right there. Negative 1 1/3, which will be 0.3 repeated. I'm going to put that right about there. And I'm just going to bring this down and go into this one. Negative 1 1/3. And then negative 7/8 will fall before it, so I'm going to assume that that's 0.9, so I'm actually going to put it like probably right about here. Negative 7/8. Those would be my points. Number 11, identify the dependent quality. So I have the hours studied for the exam, and then I have the grade on 300-point exam. So for me, the way I would look at this is it seems as though the hours that were studied, was the higher the grade. So to me, the grade is dependent upon the hour study. So the grade is going to be our dependent variable, which is B. Number 12, Shane and Jerry played in a 3-day golf tournament. The winner is determined by combining the daily scores, and the person with the lowest score is the winner. The daily scores are listed in the table below. Calculate the final score of each golfer and determine the answer. So, negative 3 plus negative 2 is negative 5, so that was Jerry for the first 2 days. Then we add a positive 1 to that, and his final score would be negative 4. Negative 4 plus negative 3 is negative 7. When I add a positive 2 to that, it would be negative 5, which means that is lower than negative 4, which means Shane is the winner. Number 13, order the following numbers from greatest to least. Greatest to least. So my biggest number will be 2 4/5, followed by 1 3/4. Then I'm going to go into my negatives, and the greater the negative number is actually the smaller of the negative numbers. So negative 1.7, followed by negative 2.6. Number 14, Christopher was not keeping track of his withdrawals and deposits in his checking account, which caused his balance to go below 0. When he went to the bank to resolve the problem, his balance was negative $15. He deposited some money in the account, and now his balance is $42. How much did he deposit? So I am going to do 42 minus negative 15 to find the difference between the two, because he had to cover his negative 15 to 0 and then added another 42. So 42 minus negative 15. We're going to use our rule of keep it, change it, opposite it. So now I have 42 plus 15, which would give me $57 is what he deposited. So again, he had to cover what he had already spent, which was the negative 15, and then an additional 42. Solve each problem. So I have negative 1,430 divided by negative 130. Because it's a negative divided by a negative, my answer is going to be positive, and the answer to this is 11. Negative 36 times negative 28. Again, negative times a negative is going to be a positive, and the answer will be 1,008. 1,008. You kind of can think of the movies. I know that's the example we used in class, that if you both agree on the movie, you see it's positive. If you both disagree on the same movie, it's still a positive outcome. It's when we disagree on the movies we want to see that it's negative. So that kind of helps remember. Negative 15 times negative 10 is going to be negative 150. Negative times a positive is a negative. Now we have an addition, negative 5 plus 5. Since it's the same going one way and the other, think about your number line, I'd wind up at 0. And then negative 10 minus 5, we're going to keep it, change it, opposite it. Now I have negative 10 plus negative 5, which is negative 15. Good luck studying, and if you need help, we will see you in tutorials.